Hey Math 1 students, we are going to dive into your 5.3 Ready, Set, Go notes. So please make sure you've got your packet open and follow along. The first thing we're going to talk about is these three different forms that we've been using to write linear equations. So the first one is slope-intercept form. So we have to remember that slope-intercept form is y equals mx plus b. The key feature, the key thing that you're really going to be looking at here is that y is by itself. But there's another thing I want you to make a note of. We also have to make sure that there are no parentheses and no like terms. So in other words, the right-hand side, or the side without the y, is completely simplified. Okay, and that's going to be important as we move forward and look at some examples. The other form, another form, is point slope form. So point slope form tells us y equals m times x minus x1 plus y1. And this form we're used to using if we're given just a random point and a slope so that we can create a line. For standard form, this is the newest one that we've learned. This is ax plus by equals c. So the key features that we need to pay attention to here are that x and y are together on the same side. And it's very important that there are no fractions anywhere in standard form. Okay? So what we're going to be talking about is we're going to be taking these three different forms and rearranging them into whichever form they ask us for. So in order to do that, we're going to have to do a little bit of reviewing and talking about not only rearranging, but simplifying also. So a lot of what we have to do is be able to simplify one form and then turn it into another. So the first thing that we're going to talk about is distributing. So remember, we distribute anytime we see parentheses. So we can see that this is -3 times x minus 4. So we're going to take the -3 and distribute it inside, which means we're going to multiply. So we have -3x, and then -3 times -4 gives us a positive 12. So now this expression is fully simplified. There's no more parentheses. They're gone once I do my distributing. And there's no like terms for me to combine, so I'm done there. In this next one, we're going to talk about distributing and combining like terms. So we can see there's kind of a lot going on here. But the first thing we have to take care of, again, are those parentheses. So we're going to take the 2 and distribute it inside, which again means multiply. The 4 just stays. We're not doing anything with it. So we're going to do 2 times x, which gives us 2x, and we're going to do 2 times -5, which gives us -10. So then we can see there's some like terms here. We've got a 4 and a -10, and we know that those are constants because they're both just numbers. So we can do 2x, because that's by itself, and if we do 4 plus -10, we end up getting -6. So now this expression is fully simplified. Now, I want you guys to think back to some of the other modules that we've done. We talked about a third thing that we can do when we are simplifying expressions. And that third thing that we could do is divide. So I want you guys to remember how to do this one because it's going to be really important as we move forward into some of these problems. So let's say we have something that looks like this. Let's say 5x minus 15 all over 5. So if we look at this, we can see that because there's a fraction, hopefully we can simplify it down by dividing. So we could do 5x over 5, and then we can do 15 over 5. So we're going to end up taking the numerator of our fraction, which in this case is the 5x and the 15. We're going to space them out, and we're going to divide both of them by 5. And since we had a minus sign, we're going to put a minus right there. Well, now we can use our calculator if we need to and just simplify these. So 5 over 5 is going to give us 1x, so we can just write x. And then 15 over 5 gives us 3, so we can write -3. This is going to be important, like I said, especially with this first example we're going to end up doing down here. So take a look at what our learning objective is for this one. It says I can apply properties of operations, so add, subtract, and multiply, to linear expressions in order to determine equivalence. So remember, equivalence means that we're trying to prove that two things are the same. So we're going to take this equation and we need to rearrange it into slope-intercept form. So make yourself a note first of what slope-intercept form is. It's y equals mx plus b. So we need to take these three equations that are here and rearrange them so that they look like this. So for this very first one, we've got negative 2y plus x equals 10. We're going to take this and rearrange it. We're not changing anything, and we're going to make it look like this instead. So here's that y that we're solving for. If we've got negative 2y plus x equals 10, then we know that the first thing we have to take care of is this x. So the way that I'm going to move that over is I'm going to use an inverse operation. I'm going to subtract x from both sides. Those cancel, and I'm left with negative 2y equals 10 minus x. And then for the last thing, here's my y that I'm looking for. It says negative 2y. So that means I need to divide everything by negative 2. So I'm going to divide the left side, and it cancels out. I'm going to divide the right side. So I end up getting y equals 10 minus x all over negative 2. But if we look, this doesn't really look like that, right? I can't clearly identify what my slope is and what my y-intercept is. So this is kind of a problem. We're not done yet. This is where that dividing that I talked about up here is going to come into play. So we can take this fraction and break it up. So now we're going to have, and I'm going to go ahead and write it over here, we're going to have 10 over negative 2, and then we're going to have minus x over negative 2. Now we're going to need to be careful simplifying this one here. This is a little weird, but that's okay. So 10 over negative 2 simplifies down to negative 5. And then these two negatives here, I'm going to go ahead right away and just make them positives. This is x over 2, which really just means 1/2 x. So now this is in slope-intercept form. It's backwards, so we could write it the other way too. I usually do like to have my x come first, so I'm just going to go right here and write it with the x part first. So y equals 1/2 x minus 5. Now I can see what my slope is and what my y-intercept is. We took this equation and just rearranged it. We didn't change anything about it. Okay? Let's go ahead and try another one. So for question 2, we're still trying to get it into slope-intercept form. Here's the y that I'm looking for. So this one's actually a lot easier. We've got 3x plus y equals 12. So I'm going to subtract 3y from both sides, or 3x, excuse me. These cancel, and I'm left with y equals 12 minus 3x. Again, I usually like to have my x come first, my slope come first, so I'm going to rearrange it to be y equals negative 3x plus 12. And there's my answer. That one was nice and easy. All we had to do was take the x term and move it over to the other side, and then we were done. Question 3 here looks a lot more like this example up here where we had to distribute and combine like terms. We've got parentheses, but then we've also got this random minus 6 on the outside here, so we're going to have to know how to deal with that. So the first thing we're going to do is get rid of those parentheses. We're going to take that 4 and distribute it inside. So the y stays the same, and we get 4 times x, which is 4x, 4 times 1, which is positive 4, and then the negative 6 just chills, right? It just comes along at the back. But now I can see I've got some like terms right there. So now I'm going to do y equals 4x, and if I do 4 plus negative 6 in my calculator, I know that I get minus 2. So now this equation is in slope-intercept form, and we're good to go. Okay, so now let's look at some other examples that we have. So these examples have different directions, so you have to pay attention to what they say. Now it says rearrange the equations into standard form. So just as a reminder, standard form is ax plus by equals c. And one of the big ideas here is that a, b, and c have to be whole numbers. They cannot be fractions. So if we take a look at question 4 right here, first thing we notice is that that x and y are not on the same side of the equation. So I'm going to make that happen. I'm going to take this 1/2 x and I'm going to move it to the other side of the equation. So now I have negative 1/2 x plus y is equal to 4. So this is good because now x and y are on the same side, but the problem is I have a fraction here. So what we have to do is we have to figure out what number do we have to multiply by to make that fraction go away. So in this case, because the denominator here is a 2, I'm going to multiply this side of my equation by 2, and I'm going to multiply this side of my equation by 2. You'll notice I put this in parentheses because I'm multiplying this entire side. So I have to take the 2 and distribute it inside. So I end up getting negative x plus 2y equals 8. And now it's in standard form. I have the x and the y on the same side, and there's no fractions. Okay, let's do another example. So in question 5, if we look, the x and the y are on the same side already, which is awesome. I don't have to do the first step that I did over here. But what I do have to do is I have to figure out how can I get rid of this fraction. So since it's 2/3x, the denominator of that fraction is a 3. So that means if I were to multiply this side of the equation by 3, it would make the denominator go away. But I can't just do it on one side, I have to do it on both. So I'm going to take this 3 and distribute it inside. If I do 3 times 2/3x, we can use our calculator to make sure, but we're going to end up getting 2x. And then 3 times 4y is positive 12y. And then equals 8 times 3, which is 24. So we have the x and the y on the same side. We have no fractions. We are good to go. For question 6, we can see it looks like a lot like the last problem that we just did. So we're going to have to start by getting rid of the parentheses. So I'm going to distribute. I'm going to multiply that negative 2 into the inside. So negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. And then the negative 5 just comes down. So now I can see I've got some like terms. So it's going to be y equals negative 2x minus 7. Now, if I were stopping at slope-intercept form, I'd be good, right? But I don't want it to be in slope-intercept form. I want it to be in standard form. So in order to make that happen, I need the x and the y to be on the same side. So I'm going to take the negative 2x that I have and use my inverse operations to add it to the other side. So those cancel out, and I get 2x plus y is equal to negative 7. Now it's in standard form, which is the form that I wanted, so I'm okay. This part here is so important, you guys. Please, please, please put some stars next to it. Highlight it if you've got a highlighter. This is really important. You need to pay attention to which form you're supposed to rearrange the equation into. So this first question says rearrange into slope-intercept form. So that means we need to make it say y equals mx plus b. You need to solve for y. If you look at questions 8 and 9 though, they both say rearrange into standard form. So those are going to be more like what we did in questions 4, 5, and 6. So take a look at question 7. We're going to do this one together. So it says negative 4y plus x equals 28. Here's my y that I need to get by itself. I'm going to start by subtracting 8 from both sides. Or x, excuse me. I'm going to subtract x from both sides. So I get negative 4y equals negative x plus 28. Now I need to divide everything by negative 4. So I have y equals negative x plus 28 all over negative 4. Now if the directions just said solve for y, we would be done. but the direction said rearrange into slope-intercept form. The way I'm looking at this right now, I don't know what my slope or my y-intercept actually are. So I need to go one more step. I need to do that division that we talked about. So I'm going to do negative x over negative 4 plus 28 over negative 4. So negative x over negative 4 plus 28 over negative 4. And now this is where we would need to use our calculators. But if we do negative 1 over negative 4, we get positive 1/4 x. And if we do 28 over negative 4, we get minus 7. So this is our slope-intercept form. All right, I feel like this one is probably the hardest because we have to remember how to solve for y, and then we also have to remember this division piece. Okay, I'm going to do question 8 with you also now. So rearrange into standard form. That means we need to get the x and the y on the same side, and we can't have any fractions. So if we look, x and y are not on the same side. The first thing I'm going to need to do is take this 1/5 x and move it over. So I'm going to have to subtract 1/5 x from both sides. So I have negative 1 over 5x plus y equals negative 8. Now if we look, x and y are on the same side, which is awesome, but I have a fraction, and that's a problem. So when I look at what that fraction is, it says negative 1 over 5. So that means I'm going to need to take this whole equation and multiply by 5. And I have to remember to do it on both sides. So I'm going to take this 5 and multiply it inside. So I get negative x plus 5y equals negative 8 times 5, which is negative 40. And now it's in standard form. All right, I would like you guys to do question 9 as your homework. So when I check in your video, I'm going to be checking that you try question 9. If you're confused, you can look up at what we did in question 6, so you can rewind the video and help yourself out if you need to, but I'm going to check that and we will go over it when I see you guys in class. All right, thanks for watching.